Let's continue with the derivative of our functions, but this time around we are going to derive another another derivative rule that we call the product rule. How can we differentiate the function that are actually multiplied together? If you have some functions that have been multiplied together, how do we find their derivative? And that's what we're going to explain in this particular slide. Now, but before we go to that product of function rule, of product rule as we call it, let's try to have the basic understanding of some derivative. We are not going to establish those one. We are not going to derive that one, because that's going to take it's going to take some work or some effort. So we are not going to go into it at all. So we have to know that if y is sine x, if you differentiate y, which is prime y, if you differentiate it, it's going to give you cos x. This can be established mathematically, but this is beyond the scope of this particular lecture. If you have your y to be cos x, then when you differentiate it, it's going to give you minus sine x. Because we're going to be using this understanding in this product rule when we are working it out. When you have your y to be exponential x, when you differentiate it, it's still going to give you exponential x. So with this in mind, so let's move to our product rule. If we want to establish, we are going to actually establish our product rule. Let y equals to uv. Let y equals to uv, where your u is a function of x, and your v is also a function of x. What that means is that both u and v, they are dependent on x. They depend on x. That is, there will be an element of x in the two of them. That is what tells us that we are actually multiplying two functions together, because both of them depends on x. So when you have this type of thing and you have to find the derivative of two products of functions that depends on the same variable, how do we go about it? We have to establish the formula now. So let's say that we know that we have y plus change in y is going to be equal to u plus change in u, yes, because both of them depend on x. Because originally, when you have y plus change in y is going to be equal to f of s plus change in x, yeah, and v plus change in v. Increment in this produces increment in the two. That's what happens. So we can expand this one out, and this is going to be uv plus u change in v plus v change in u plus change in v change in u. Expanding this one out, and that's what we have. So this is y plus change in y. So the next thing is to make our y based on the way we established our first principle. We are using the approach of our first principle here, the second approach that we use. So this is change in y is equal to uv plus u change in v plus v change in u plus change in v change in u. Then my y will go to that side. And don't forget our y is uv. So of course, my uv can cancel my uv. Moving to the other side. So this change in y is equal to u change in v plus v change in u change in v plus v change in u plus change in v change in u. Then it can be divided by change in x. Everything can be divided by change in s. And this can give us a total derivative when change in y goes to 0, change in s goes to 0. That's why you have to watch our first lecture on this to get this right. This is the y, the x is now equals to, this is u change in v over change in x plus v change in u over change in x plus change in v change in u over change in s. The two product does not depend on x, so that's going to be 0. And this is the y, the x is equal to u change in v over change in x plus v change in u over you are changing x. And this one is called the product rule. It's called the product rule. This is the rule that you use when you are given a question that the two functions are dependent on x. We are going to give some series of example shortly. Here now we are given this question. We are given y equals to s cubed sine s and so on. Then we have to find the derivative of each of these functions. Looking at this function, y produces two separate functions, which is s raised to the power 3 times sine x. Sine x is a function that is different from s raised to the power 3. There are two different functions entirely. This is a trigonometric function. This is an algebraic function. So it means that these two functions, and if you look at them, they depend on x. They are functions that depends on x. That is the main reason why we will consider them as product of two functions, right? So since we have established that they are product of two functions, we are going to use function, and we are going to use the product rule. We are going to use the product rule, and the product rule is the y, the x is u dv dx plus v du dx. U dv dx plus v du dx. I think I made a mistake in my last slide, and that one is we are supposed to write it as dy dx after I've taken the derivative to approach them. It's going to be dy dx equals to u dv dx plus v du dx. That is the product rule, not the delta that we used in the previous slide. That was a mistake on my part. So let's implement this now. We have our u. Our u will be the first function. I'm considering the first one. My y is s raised to the power 3 sine x. So all we just need is the input from here. My u is s raised to the power 3. My v is sine x. My v is sine x. So I need my dv dx. So my dv dx is to differentiate my v with respect to x. When you differentiate sine x, it's going to give you cos s. I established that before. Then when you differentiate my u with respect to x, this is my u, and this is going to be 3s raised to the power 2. So putting this entity in my formula, we have u dv dx. My u is s raised to the power 3, dv dx is cos s, plus my v, which is sine s, and the u dx is 3s squared. So finally, this is s cubed cos s plus 3s squared sine s. That's what we'll get when we are done factorizing, when we are done with the differentiation. So we move to the second one, which is y is equal to s raised to the power 4 cos s. These are the basic questions that you can encounter. Of course, we have the complex one, but basically this is the approach of implementing the product rule. So we have my u s raised to the power 4, my v cos x, then the y dx is going to be, I need my du dx, of course. My du dx is 4s raised to the power 3. My dv dx is minus sine x. Then my dy dx is u dv dx plus v du dx, and that is going to be u dv dx. My u is s raised to the power 4, u dv dx, that's minus sine x, plus v, which is minus sine x. Sorry, my v is cos x, v du dx, s raised to the power 10. Then this is minus s raised to the power 4 sine x plus 4s raised to the power 3 cos x, and that's what we have. Then the last one is very simple also. This is number 2, this is number 1. Then the last one is also very simple, and that is y equals to s to the power 5 exponential x. So in that case, what we have here is my u is s to the power 5, my v is exponential s. Du dx is 5s raised to the power 4. The v dx is exponential x. So the y dx is u dv dx, which is exponential x, plus my v du dx, which is 5s to the power 4. Then finally we can have it as s to the power 5 exponential s, or we can just factorize exponential s among the two. Exponential s and s to the power 4 is common, s to the power 4 exponential s, just to factorize, and this is going to be s, when you move s to the power 4 is going to be s plus 5. It's just factorizing here that we do. So that's all about the product rule, basically speaking. More advanced approach will be covered in advanced topic. Thank you, and we'll move to another aspect.